Let's have a look at question 2 in this video. So we have a population with two types of people, C's and D's. Let's just call them cats and dogs to give some meaning to the question. Now, interactions among them are different, and here we have the payoffs. When cats interact with each other, we have a 6 outcome for each. So I put this in the table here. Cats and cats, we have 6 and 6. Then cats and dogs, 8 for dogs, 0 for cats. So dogs would dominate. Here I wrote dogs and cats, so we have 8 for dogs, which is the first player. If we read it from this row, 0 for the second player, which is the cats. And the other way around, cats and dogs, meaning 0 for cats, 8 for dogs. And then dogs and dogs, dogs and dogs, 4 and 4 in expectation. And we also know that there are invisible lenses at the cost of 1, so lenses are 1, to distinguish between the types of people. Now, let's have a look at first question. What will be the equilibrium population shares of these people? So what does that mean? That means we have a proportion, right? We have a proportion of cats, a proportion of dogs. So let's call the proportion of cats X. So that's going to be the percentage, the proportion of cats in the population. And then we're going to call 1 minus X the remaining, because anytime proportion, percentages must sum up to 1, to 100%. So this is the proportion of dogs, the remaining. Now the question is, what's going to be this proportion? It means we have to have a level that makes the cats indifferent between buying these lenses to distinguish and not buying the lenses to distinguish. And why would we do that? Well, because if we look at the cats, we can clearly see that cats have an advantage of buying this buying these lenses, because if they can screen the cats from the dogs, they can only cooperate between each other and have the highest possible outcome, 6 and 6. Otherwise they lose completely to the dogs, so they lose completely. They have nothing left from the interaction with dogs, so they clearly have an incentive to go for lenses, meaning that if a cat goes for lenses, the expected value of a cat including the lens would be 6, because for sure they're going to interact with cats, but then they have to pay for the lens 1 unit. So 6 minus 1 would equal to 5. Now what would be the expected value of a cat without the lens? So expected value of a cat without the lens. Well, we know that that's gonna depend on probabilities. So with the probability of X that they interact with cats, they would get 6. But then with the remaining probability that they interact with dogs, they would get 0. So 1 minus X times 0. And if we solve the math, that would be just 6X. Meaning that if we want to find out the indifference point between buying the goggles, the lenses, and not buying them, then we would have the following. The expected value from the expected value of the cats with the lenses must equal, let me go a bit zoom out here, because not enough space, so like that, should equal to the expected value of the cats without the lenses, meaning that 5 should equal to 6x, which means that x is equal to 5 over 6, and we're going to interpret this right now. X equals to 5 over 6. What is x? That is the proportion of cats. What does that mean? That means that if we have at most 5 over 6% of cats, then the cats have an incentive to buy the lenses. But if it is above that, they have no incentive to buy the lenses, and we're gonna see why that is the case. Let's have a look here. If we put it on a number line, we're gonna understand better. So this is going to be the number line for X. It starts from 0 until 1, and then we can see that if it's 5 over 6 on this range, then there is an incentive to buy the lenses, so the cats are going to invest in the lenses. Above that range, there's no reason to go for the lenses, so over here there is no reason to buy the lenses. And why is that the case? Well, because as long as we have a ratio of cats that's less than 5 over 6, then we still have the probability that they might interact with dogs. And in that case, to hedge against this probability, it's worth to buy the lens, to protect for that. Once we reach 5 over 6, then the cats are indifferent, because in expectations they have the same value. Either 5 if they buy the lens, or 6 times 5 over 6, which is also going to be just 5 without the lens. So at this point they're indifferent, but have a look at the last range above 5/6. If there's so many cats above 5/6 percentage of cats, it means that there are so many of them that in expectations the value is gonna be higher. And let's just give an example. Let me calculate it here right now. 5/6 is 0.83. Let's say we would have 0.84 cats. So that means 84% cats. 0.84. Let's solve the math. The expected value of the cats without the lenses, assuming there are 84% of them, would be 6 times 0.84, which is equal to 6 times 0.84, 5.04. So that would be 5.04, and we clearly can see that this is higher than the 5 with the glasses. So that's why, as long as there are so many cats, that it makes it better to not buy the glasses, since they just have a better chance anyway. Since there are so many of them, the likelihood of meeting with cats is high, the likelihood of meeting with dogs is lower, so they all just gonna take the risk. Whereas in this case we saw the opposite. They still have the risk of interacting with dogs, and that risk is quite high, so they would rather hedge it. Now let's leave it like that for this video, because this is not an easy question. In the next video we're gonna explain more what's happening on these ranges, who is better off.